In this video, we will continue to explore the bug on the fan problem as a way to explore how different quantities in the situation vary together. Recall that as the angle swept out by the bug increases, that means as the amount of openness in the angle measured in radians increases, then the arc length, or the distance in feet, traveled by the bug will also increase. It is important for us to be able to understand the difference between the quantity, the angle that is swept out by the bug in radians, and the second quantity, the distance that the bug travels in feet. The first quantity is a measure of the amount of rotation, and the second quantity is a measure of distance. In Module 7, Investigation 3, Questions 1 and 2, you are invited to imagine what other quantities we might measure and track as the bug travels around, riding on the fan blade. As you name quantities in Question 1, be sure to include the object, the attribute, and the units. Question 2 specifically asks you to track the bug's height above the horizontal diameter as the angle the bug sweeps out from the starting position increases. Here is the horizontal diameter that the question is referring to. And if the bug has swept out this angle, then the height above the horizontal diameter would be this positive distance. Now, imagine that the bug is continuously moving around. Draw on your diagram to help you track the bug, and then describe how the bug's height above the horizontal diameter changes from moment to moment as the angle that the bug sweeps out from the starting position increases. Then, provide clear answers to all parts of Question 2. Fully answer how the height above quantity changes, as well as how the rate at which the height above is changing with respect to the size of the angle swept out by the bug. In Part D, when you graph the values of the quantities of interest, place values for the measure of the angle of rotation measured in radians on the horizontal axis, and place the values of the bug's vertical distance above the horizontal diameter in feet on the vertical axis. Remember that when the angle of rotation is pi over 2, we see that the bug is at its maximum height above the horizontal diameter, which is 2.6 feet. Also, when the angle of rotation is 3 pi over 2, we see that the bug's height above the horizontal diameter is at its smallest, which is negative 2.6 feet. Work with the sketch to determine other simultaneous values of these quantities, and plot these as points on the axis provided. Now, Part F is very similar to Part D, but it asks you to measure the height above the horizontal in radius lengths. This means that when the angle of rotation is pi over 2, then the height above the horizontal diameter measured in radius lengths is 1, because the bug is 1 radius length above the horizontal diameter at that point. Think carefully about all parts of Question 2 and provide your answers. Answer all parts of Questions 1 and 2 in Module 7, Investigation 3, using your instructor's preferred method by the time and date that your instructor has identified.